In 4.5, we're going to use taking square roots of both sides of an equation to solve quadratic equations. So first of all, that'll take a little bit of recognition on our part that we can use this method, and it'll also require us to know something about square roots. So the first thing we need to know about square roots is that if we multiply, like if we take the square root of two numbers multiplied together, that's equal to the square root of a times the square root of b, and that shouldn't come as a big surprise that that's also the same as the square root times the square root of a. You can reverse the order because we're just multiplying. So just an example, square root of 18. We can make that the square root of 6 times 3, and that'd be the square root of 6 times the square root of 3. The reason this is useful at times is, say we didn't factor it that way. Let's factor it a different way. 9 times 2. Why is this good? Because we can split this up to the square root of 9 times the square root of 2. And that's good because the square root of 9 is a whole number. The square root of 9 is 3. So 3 times the square root of 2 is what we call the simplified version of the square root of 18. If we were asked to simplify the square root of 18, 3 times the square root of 2 would be simplified, because we can't factor this anymore and then pull out another perfect square like we did with 9. Okay? So another property is the square root of a fraction is equal to the square root of the numerator over the square root of the denominator. So that would be useful if we had, say, the square root of 4 halves. Then we would get the square root of 4 over... No, that's not a good example. Let's do the square root of 4 thirds. Then we get the square root of 4 over the square root of 3. And the square root of 4 is 2 over the square root of 3. Okay? Now this is technically, I don't know, improper. We'll look at how to fix that later. But for now, this is fine. It's improper. It's not wrong. It's just not proper. We'll fix that in the sample problems video. And the last thing that you really need to know is, let's just take a simple example of an equation that we might use this method to solve. So how about if x squared minus 9 equaled 0? So what would we do in this instance? We might take x squared minus 9 and rewrite it so that we have this middle term, like we've done so many times before. Okay, my computer's not letting me draw this line here. Thank you. So equals 0. And then we'd say what multiplies to make negative 9 and adds to make 0. So then we go x plus 3 times x minus 3 is the factored form. So x plus 3 equals 0, or x minus 3 equals 0. So x equals negative 3, or x equals 3. Okay. Here's a much faster way. Since there's only one, what I'm going to call an instance, there's one instance of an x variable, why don't we add 9 to both sides? Okay. And remember that with an equation, this goes all the way back to our first days of talking about equations and what equations meant. These two sides are equal, and we can do anything to them as long as we do it equally to both sides. I could add 3 to both sides, subtract 7 from both sides. We just added 9 to both sides. So as long as what I do is the same on both sides, I can do it to both sides. So how about if we take the square root of both sides? Why would we do that? Because the square root of x squared, let's just realize what this means. X squared means x times x. And what is the square root of a number? Well, the square root of a number, like the square root of 9, it just means what's a number times itself that gives me this number. So what's a number times itself that gives me x? Or it gives me x squared? X is x times x. X times itself gives you x squared. So this side is just x. And so now we just have to find the square root of 9. Now the square root of 9 is a little bit tricky. When we take the square root of 9, like we initiate that action, and we say, let's take the square root of 9. We're looking for a number, any number, even multiple numbers, that will multiply by themselves to make 9. Of course, we know that 3 times 3 is 9. That makes sense. But what about this possibility? Negative 3 times itself, is that 9? It is. Negative times negative is positive. So not only positive 3, but negative 3. So this is what we write, plus or minus 3. Okay. So this property here, let's just block these off here into separate sections. This property here is something that you need to be familiar with. Also, this here. And lastly, that we can take the square root of both sides and then take the square root of that number, and that gives us both such solutions, which is consequently the same solutions we got from doing it this kind of long way, factoring, setting them equal to 0, solving for x. We got positive 3 and negative 3, positive and negative 3 here. All right, so we'll go into more detail and such in the sample problems video.